Started off right. Huh? Oh, God. And then I do that every time. And then I have stickers on things I don't want stickers on. Okay, goodbye, stickers. We love change of base formula. We actually already did this. So change of base means like you can take a log and write it as a log divided by a log. Right? I do that in my calculator. It's what I show you guys all the time. So we're just going to skip right down here. This is technically a formula, and it's technically a log law, is that you could take any log and break it into two logs divided by each other as long as you give them the same base. Right? Usually, I do it like this. So I take log base 2 of 8, and I rewrite that as log 8 divided by log 2. That's typically what I do because my calculator can handle that. This is allowed because they're both base 10. I'm making this base 10, I'm making this base 10. You just don't write the 10. Yeah, it's like invisible. Technically speaking, you could choose any base. I just do base 10 because the calculator knows how to use base 10. But like I could take this and I could write it as base t. So I could rewrite this as log t of 12 divided by log t of 2. So you could choose any base. It's just base 10 makes sense because our calculator knows base 10. Again, it's a log. I don't spend a lot of time on it just because we do calculations like that all the time. It's just how I use my calculator. Okay. This is talking about log base 10. It talks about actually using your calculator and evaluating logs. So if you want, pull out your calculator. We'll do a couple of these really quick. We're going to evaluate. That means calculate, right? We're going to try using change of base. So even if you have the log base function, just try change of base. This thing would be rewritten as log 15 divided by log 3. I'm changing the base to both be base 10. You throw that into your calculator. I need a calculator for that. Log 15 divided by log 3 is 2.46. Change of base. On your calculator, right, the log button's on the right-hand side. Go over to question B. If you were to read that aloud, that is 2 times log base 5 of 30. So if you wanted to change a base this, the 2 is still a coefficient, and then it's just the log that changes. So log 30 divided by log 5. That 2 is not a part of the log at this point in time. So you could put that into your calculator, 2 times log 30 divided by log 5, and the answer is 4.22. It's actually 4.23 after you round it.
Am I allowed to write the 30?
Yeah. Yeah.
Because I got the same answer.
Yeah, same answer. And we're going to learn that in about 5 minutes too.
Okay.
This one down here. That doesn't have a base. So if there is no base, no like little number, what number is there? Right, it's an invisible 10. You could change a base this. I mean, it'd be a little ridiculous, but you could. So to change a base it would go log 40 divided by log 10. That technically works, right? Like you're doing the same base, so it's fine. You throw it in your calculator, it's the exact same thing as just saying log of 40, which should be 1.60. I see little purpose of taking something that's already base 10 and then changing it to log base 10. I mean, you could do it. Last one, D, same idea. I could change a base this to be log 10 of 8. So I just go log of negative 8. And I get log 4 on the bottom. If you try calculating this, you get, do you want me to show you? I don't think I'll have to show you. You should get error. Yeah, it says non-real answer, quit. Okay, error. We encountered this yesterday. Why is this an error? Why is it not possible? Yeah, this negative can't happen. Remember what logs are saying, right? So if you look back at the original log, this is saying what exponent could you put on 4 to turn it into negative 8? It's not possible. There's no way you're ever going to have 4 to the power of something turn into a negative number. It's just not possible. So you can't have arguments that are negative like that. Therefore, it's got no answer. You could put no solution, right? Whatever kind of tickles your fancy. No answer, no solution, NA, it all kind of works. You'll see me put no solution. For the record, the reason your calculator says non-real answer is because if you go a little bit further in math, like university level math, you will learn about something called imaginary numbers. So it's like numbers that don't exist but could theoretically solve problems like that. It's a terrible concept, and I recommend never learning about it. Isn't that nice and encouraging? But that's why it says non-real answer, because there is technically an answer if you're someone who's much smarter than I am. I have no idea what the answer is. Imaginary numbers, I think, are I's. I think it's like, it's when I dropped out of math. As soon as imaginary numbers became a thing, I was like, see ya. Got out of that. Like, now let's learn about things that aren't real. Like, no, let's not do that. Let's learn about something useful instead. Log laws. These are properties of logs. We got a lot of different log laws there on the right-hand side. On the left-hand side are your exponent laws that we should already be pretty familiar with. The log laws technically do come from the exponent laws. Now, I'm not going to spend time like showing you how they connect to each other. You're just going to have to trust me, even if you have trust issues, that these are connected to each other. These log laws. The first 3 are probably the biggest ones. These ones are kind of just like random facts that are nice to know and useful to know. They'll pop up a lot. But these are the 3 like true log laws. First log law. You could take a log, and if the argument has 2 things multiplied together, so this is m times n, right? Multiplication of the argument. Then you can actually split this up into 2 separate logs that are now added together. So I go log of m plus log of n. Multiplication of arguments becomes addition of logs. You could go the other way too. So if I had 2 logs being added together, I could write them as 1 log, where I multiply the arguments. And we'll go both directions. Next log law is if you have an argument that is dividing. So if I have m divided by n. Arguments that are dividing can then be subtracted. So I would go log of m divided minus log of n. And the one that's actually been talked about a couple times in this class is if you have a log where the argument is an exponent, like that. That exponent can actually be rewritten as a coefficient. So instead of squaring the argument or something like that, you could put it out front as a coefficient. And now it becomes n times that log. And notice that the exponent is now gone. Our 2 random kind of log laws are these two. I call them random. They're really not random. But they're much more logical and easy to follow. Okay? The reason why they're more logical is if you remember what a log means. Okay, so a log is the exponent needed for A to become A. So what exponent would you have to put on this base to turn it into that argument? They're already the same thing, so just 1. So that's why this would equal 1. Same base, same argument equals 1. Someone's freaking out there. The second random log law has to do with if the argument is 1. Because this would be what exponent do you put on A to make it equal to 1? And we know that anything to the power of 0 would equal 1. So anytime the argument is 1, the whole log is 0. Hey, I'm actually going to write that beside our little log law. Same base. Same argument. I've been avoiding using the word argument officially written down because I'm not confident in that terminology. But that's what I call it, so let's all just call it that. And if I'm wrong, don't tell any other teachers I said that. Did she call it the argument? I got it right. Yes. It's a lot of pressure on me there. So same base, same argument. The log equals 1. Okay, the whole thing will equal 1. The law below it is trying to tell us that if the argument is 1, the log equals 0. Doesn't matter what the base is, because anything to the power of 0 will turn into 1. And that's kind of the rule we're trying to pull on. Something I've been doing more of is writing, like actually writing out what I'm trying to explain. Do you think that helps at all? When you see it written like that, does that yeah, okay, that actually helps. Yeah? Yep. Cool. I feel like it does help. Something I've been trying to do more of. I learned, so part of my job, this is definitely a pause video. Now that you know too much about my life. Yeah, I tend to do that. I'll try not to too much.
You should try to more.
Yeah, I'm recording again. We're good. And my little dot is back. Okay, let's evaluate this. So evaluate means calculate. We're going to try to calculate without a calculator. Okay? Because that is a good handy skill. But more importantly, we're going to try to see if we can't use some log laws here. So the log law I'm going to use is if I'm adding logs, I can multiply the arguments. It's important to note this only works if you have the same base. They're both base 5, which means this is allowed. Different bases, you can't use that log law. This means I now have log base 5 of 100 times 1 over 4. Okay. 100 times 1 over 4, 100 times 1 is 100, divided by 4 is 25. That means this is log base 5 of 25. All right, so I took my logs, I wrote them as 1. I simplified the argument, and now I can actually calculate this log without my calculator. The exponent that you would put on 5 to equal 25 would be 2. 5 to the power of 2 would become 25, right? That's what logs are doing. The exponent needed on the base to become the argument is 2. You're always going to have your calculator, so don't stress too much. But when it comes to, if this question had letters on it, right, you'd have to know a little bit of what you're doing. Yeah.
How do we write out that 2?
Just
Equals
2.
two.
This whole thing would be 2. You put that in your calculator, it's 2.
But like, would we not put like blank equals 2? I don't know. Or just
No, just 2 is good.
Okay. So whenever it's doing evaluate, that's just what it's asking for?
Yeah, just calculate it.
Like, wait, when it says evaluate, it just wants like what the log is.
What the value is. Like evaluate means calculate. So those words are like interchangeable essentially.
I don't know what I'm talking about. Yep.
Okay, this one. Looking at this, I'm subtracting. I have the same base. Subtraction means I can divide the arguments. So this is log 2, 384 divided by 12. You're good. You can simplify that argument. I don't know what 384 divided by 12 is. 32. It's like it has to be something that's 2 to the power of something. And again, you could ask yourself, what exponent on 2 would become 32? 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32. Again, you'd have your calculator. I know, you could calculate it. The idea here is the log law part. Notice how I used log laws and then could simplify. And that's the kind of key. Because now, you're going to get to questions like this. We're going to have to use log laws on variables. So it says, use the properties of logs and exponents to simplify the equations. Simplify equations. That means we're going to try to write this as one log and then simplify it as much as we possibly can. Looking at the first question. I am adding logs. If I am adding logs, I multiply the arguments together. What people will mix up is that there's adding happening in the argument. That's irrelevant. Like, you can't do anything with that. The law is that you can add logs. We have no rules about arguments being added together. There's nothing we can do about that. But we can combine the two logs. This will become log A plus B times A minus B. The arguments are now multiplied together. Perfect. You can simplify that. So, multiplying these together, little bit of FOIL, right? Like distribution. A times A would be A squared. A times B would be negative AB. B times A would be positive AB. And then B times negative B would be negative B squared. Yeah, those middle terms you'll notice, I have a positive AB, I have a negative AB. Those can cancel each other out. That means this simplified to be log A squared minus B squared. That is my simplified logs expression. If you factored it, it would go right back to here. Yeah, and it wouldn't be as simplified. So
that's for factoring.
Yes, that's if we're factoring something. That's all good. It's impressive that you remember that terminology. That's good. So multiply the arguments, expand it, simplify it. What you don't do here, and I think it is important to see what a mistake would be, is people would see that subtraction and think division, right? Because we know that there's like a log law about subtracting. That's if you have log minus a log. That's not what you have here. You have subtraction in the argument. There's no rule for that. So this is done. Let's slide over to this one. Hey, we have lots of log laws here. We need to apply them in the proper order. Okay, so log laws that I can see. I see a log minus a log. That's going to be something. I see a log plus a log. That's going to be something. I also see coefficients. Those are log laws as well. So I have lots of different laws here that I have to apply. The order matters, okay? You cannot do the subtraction or adding laws if there's a coefficient. Because I have nowhere to put that, right? If I was to combine these two things using division, I don't know where this 3 would go. So the first rule you're going to deal with is the coefficients. And our log law for coefficients was, if you have a coefficient, you're going to move it to the exponent. So it now would look like this. Log of A minus log of B to the power of 3. Plus log the fifth root of C to the power of 5. If I had the fifth root to the power of 5, those things would cancel out, and I would just have C. I'll write that up here just so people know where I got that from. Right? Fifth root power of 5, those things would cancel out, and I just have log of C. Wonderful. So I did my coefficient log law. Now I need to do my division and my multiplication log laws. If there was brackets here, I would obviously have to deal with the brackets first. What I mean by that is if you had like brackets here saying do these logs together first, then you'd have to do that. If there's no brackets, I just go left to right. Okay, so I'm just going to go log A minus log B to the power of 3. I notice that this is a subtraction of logs. That means I'm going to divide those together to become log A divided by B to the power of 3. Right? Subtraction becomes division. Plus log C. Subtraction became division. Now I have multiplication. Right? Adding logs together becomes multiplication of the arguments. When you multiply something that's a fraction, it just goes to the top of the fraction, right? You would have learned 20-1, I would have been like top goes to top, bottom goes to bottom when you're multiplying. Okay, so this is like A divided by B cubed, C divided by 1. So the C goes to the top, the 1 would go to the bottom. Top with top, bottom with bottom when you're multiplying. This becomes log AC divided by B cubed. That is now 1 log. Yes, sir.
Do you get a different answer if you start with log b cubed multiplied by log a?
Yeah. So if you had done the b cubed plus the log c, you'd have a divided by b cubed c, because the c would then go to the bottom because you multiply them together first. Which is a problem. Yeah, that's why you gotta go left or right. In all honesty, I believe when I've seen questions like this on tests and diplomas and whatnot, that they would do this if they wanted you to do that first. They would bracket it up and they would say, like, do these log laws first because it's in brackets. Then you can go to the next one. Even something like this, you might see this. Like, you might see them go bracket, bracket. Like, you might see that. So that they're making sure you do something first. Yeah. Of course. Yeah.
The second part of the equation was subtraction. Would you still start with that one? Or
Yep.
Would you just go?
Yep, still left or right. So if this had been a subtraction, I would still do division, and then I do division, so it would go to the bottom, and the C would be on the bottom. Cool, I think I got one more down there, right? Okay, which log law do we have to apply first? Coefficients, yes. I heard division about 15 times in there. So yeah, coefficients, yes. Like the coefficients got to go to the exponents first. Then we'll deal with the rest of the log laws. So this would become log x minus log y to the power of 3 minus log z to the power of 2. Like that. Then left to right, I usually try to only do one log at a time. So if I saw this, I would then make the first two combined to be x divided by y cubed. And then I would deal with the second log that's subtracted. That's how I do it. I know you could do like multiple in a row. I just find it easier if I show my steps and only do one log at a time, right? So this would become log x y cubed z squared. It's division, so the z squared goes to the bottom. Honestly, that's like it for log laws. Now, the hard part about log laws is they don't usually tell you to use log laws, right? They give you a question and then you have to realize, oh crap, there's a log law question and I need to do something to these logs. This is nice because we knew it was a log law question, right? It said use log laws. Actually, it said whatever, use the properties of logs. I don't know. Same thing, right? It told you to use these rules. You're going to notice when you get to your practice questions, it doesn't say that very often. It just gives you a question, and you have to identify, oh, hey, there's some rules I could do here, and apply those rules. That's the challenging part. Let's look at this. This is definitely like a sample diploma question. So it probably came from an old diploma. It says the student's work to simplify a logarithmic expression is shown below, where a is greater than 1. Again, that a greater than 1 really doesn't do anything. It's just defining the problem for you so that it's an actual question that could exist. In which step was the first recorded error made? Okay, ignore the answers. Let's look at their work. The trick to these problems, they're actually showing up less on diplomas, I find, but they do still show up. The trick is not to figure out what they did differently than you would do. The trick is to figure out if they've done something mathematically false. Like, did they do something that's not allowed? So they started with this problem, right? Then they changed it to this. So let's try to figure out what's changed here. Well, if I look at step 1 and I compare it to step 2, I notice that all the coefficients are now gone. They don't exist anymore. That means they must have done something with those exponents. We know that those coefficients would multiply to the exponent. Right? So let's look at their exponents and see if they've done it right. They had 4 turn into 8. That makes sense because 2 times 4 would become 8. This one. That 3 would go to the exponent. An exponent with an exponent is multiplied. 2 times 3 would be 6. So that one's right. Then their exponent 3 became a 12. Well, 3 to the power of 4 would be 3 times 4 is 12. That's right. That means step 2 is good. Now, from step 2 to step 3, try to identify what they've done and if that's okay. Looking from step 2 to step 3, they combined everything to become a log. Right? They've got one log now. Did they do that properly? No, they did not do that properly. The reason they did not do that properly is because of where they put their x to the power of 12. If you were to combine these properly, you would have x to the 8 divided by x to the 6. And then you would be multiplying that by x to the 12. It would go to the top. This would have been the correct answer had it been minus log x to the 12. Then they did it right. It wasn't minus, it was plus. This should have gone to the top. That means their first error is here. I always get the question, when we do these problems on a test, they're like, did they make the error in step 2 or step 3? Like, I see the mistake, but it's in between here. Right? That's what I always get. It's from here to here, so it's in between. The first statement that is no longer mathematically true, that's where their mistake is. Okay, this is not mathematically true. This was mathematically true. That's it. Step 3 is gone. And just like that, my computer starts to die. It's curious, hey? It always seems to kind of be at that same limit. Maybe it's a sign. All right. These questions. This is what I mean by, like, they're not going to talk about log laws. It's going to ask you a question. It doesn't even mention log laws, property logs, nothing like that. It just gives you a question. And you've got to identify that you know log laws. So it says, given that log base b of a equals c, where a and b are greater than 0 and b can't equal 1, the expression log b a to the 5, b to the 3, written in terms of c is. Woof. Okay. That is a lot to digest. Let's try to break it down. So it says, given this. So they gave me some info. Then they defined that info. Again, this doesn't make a difference to us. So A, B greater than 0, B doesn't equal 1. It's irrelevant information to us. It does matter. The reason it matters is because they're saying, like, A can't be negative. Because in a log, like, A can't be negative. It's not possible, right? They're defining it so that it's actually a real question. But at the end of the day, it makes no difference to what we're going to do. All right? It just kind of adds to it and makes it a little bit more scary when you read it. But it really means nothing right now. You shouldn't cross it out, but I'm going to. The expression, then they give you this wild thing. Log b, a to the 5, b to the 3. Written in terms of c. In terms of c is. They want you to take that expression and change it so that the letters are now C instead of A or B,
Like all of them?
if possible. And it is possible. How is it possible? Well, two things I'm going to identify. First thing I'm going to identify. In this, I have two logs here. Because I have arguments multiplied together, I could split that into two logs. Agreed? Perfect. Let's do that. And that's going to be key to us. Because by breaking that up into two logs, I'm going to identify something else. I'm going to identify that the first log is base B with an argument of A, which is exactly what they gave me up here. Base B with an argument of A. So I can definitely change this into C. In some way. We'll get there. But see how it's kind of leading me. Base B, argument A. Base B, argument A. The second log doesn't have A at all. But it does have same base, same argument. And if I was able to get it same base, same argument, I know that that will always equal 1. So I can get this in terms of C. This one's going to turn into a number. This one's going to turn into C. The way that we're going to make that happen is by using our next log law. What's the next log law that I have here I could use? Yeah, the exponents. We know arguments with exponents could be coefficients. So this now becomes 3 log B. Oh, sorry. I was doing the other one in my head. 5 log B of A plus 3 log B of B. And now I can change things to be in terms of C or change them to be numbers. Right? This guy right here, this log B of A, yeah. It'll come back, right? Right? Hey, there we go. This, they told me log base B of A is C. So this is 5C. The 5 is the coefficient. The log turned into C. Next one. This. Log base B of B is 1. So that means plus 3 times 1. To finish that off, I should do the 3 times 1. So this is 5C plus 3. Now I'm in terms of C. The only letter left is C. The actual log laws, not that crazy. Knowing when to apply them and how to apply them, that's a skill. And that's one of those skills that you're only going to get good at from lots of practice. It's one of those things I show you the log law, easy. Then we do a question with log laws, and you're like, holy smokes. All right, so make sure in your practice book you're going through and trying these. You'll get a wide range of questions. There'll be some that are straightforward, and then you're going to get some that are challenging like this. Okay, so give it a shot. Am I okay to move on? We feeling all right? Mercy? White flag? All right, we got one more. So we got this guy. If log a of 2 equals p and log a of 7 equals q, then determine the value of log a of 28 in terms of p and q. So I want to take this and I want to change that into p's and q's if possible. Always use your p's and q's. Also important. The people who've heard that from somebody are like, yeah, I get it. Yeah. The stuff at the beginning was like rules, right? They were given this. Here's a rule. Here's a rule. If I'm wanting to change this into p's and q's, that means I need to change this into log a of 2 and log a of 7. Is that fair? That's the only way I'm going to turn it into p and q, is if I can somehow find these things in there. The way I could do that is with log laws. So for the number 28 can be rewritten as multiplication. What are two values that multiply to be 28? 7 and 4, sure. I could redo this, right? 7 times 4. I can do that, right? And now I see part of my answer. Log A7, log A7. Yeah, partway there. The other one is log A2. I don't have that yet. I have log A4. Yeah, you could do 2 to the power of 2, or you could do 2 times 2. Both would work and both would get you the same answer, right? I could break this again one more time to look like this. Log A7 times 2 times 2. That's how I see it. If you see it as 2 to the power of 2, do that. It'll still get you the same answer. You're just going to have to do your exponent log. And now I kind of see my bases and my arguments happening here. I just got to break them up into singular logs now. Multiplication means I'm adding logs. So this would become log A of 7 plus log A of 2 plus log A of 2. And I've created P's and Q's. This is Q plus P
Sorry for the
plus
interruption.
P.
Just want to remind everyone that today, tomorrow, and Thursday, there will be cupcakes and roses for sale in front of the office. And they will be delivered during block 4 on Valentine's Day. So if there's somebody you want to get a cupcake or a rose or both for, stop by and do that.
I'm going to finish this. Yeah, there's lots of time to answer questions. So change these into P's and Q's. P plus P is 2P. Eli.
So, can you just run before? Did you get different?
Okay, that's a very good question. That's why I wanted to make sure we talked about it. So, Kennedy had brought this up earlier, that she was saying instead of 2 times 2, do 2 squared. Just wait. Hey, I'm answering it for you, but you guys got to stop talking. Gentlemen. Joel. I know, you're right. But other people want to see the same answer, right? like this.
I'm sorry.
It's okay. You would do this instead of 2 times 2, you did 2 to the power 2. This becomes the
Jesus,
coefficient.
Would you return to your classroom, please?
Like this.
That's a really stupid
David Dobbins, please return to this classroom right away. Thank you.
Becomes the front. This is P, so it becomes 2P. So same answer.